So first of all, just let me know if my voice is audible to you and my video is visible to you. Yeah, please. Am I audible and visible? All right. Thank you. So in the previous class, we have covered a standard equation of an ellipse, that is x square upon a square plus y square upon b square equals to 1. All right, we have also derived that. Then eccentricity is under root of 1 minus b square by a square, which is under root of 1 minus minor axis upon major axis whole square. Then we understood about the vertex of the ellipse, major minor axis, center. Got it? Then latest rectum is 2b square upon a. That is twice of semi-minor axis square upon major axis. Then formula for eccentricity we have done. Then if it is an erected ellipse, like major axis along the y-axis, then parameters about that we have done. Then very important, we have done the focal distance property. The distance of any point from the focus is E times its distance from the directrix. And from that, we got the focal distance property as PS1 plus PS2 equals to 2A. Got it? Focal distance property is PS1 plus PS2 equals to 2A. Now, after that, we have done equation on this property. And now there we are. So, now we will start with something which is not there in the school syllabus. First of all, auxiliary circle. All right, auxiliary circle and eccentric angle. So what is the auxiliary circle of an ellipse? So in an ellipse, circle drawn taking major axis as diameter is called the auxiliary circle. Got it? A circle described on the major axis as diameter is called the auxiliary circle. Means if it is the ellipse I have, and now I draw a circle taking major axis as diameter. Like this. So if a circle is drawn taking major axis as its diameter, so in the ellipse, if I have the ellipse as x square by a square plus y square upon b square equals to 1 and a is more than b. That means x-axis is going to act as the major axis and length of major axis will be what? Length of major axis is 2a. So circle drawn taking this major axis as diameter means x square plus y square equals to a square. This is what we call auxiliary circle. Auxiliary circle. So circle drawn taking major axis as diameter is called the auxiliary circle. Got it? Now see, what is eccentric angle? There is a point on this circle as we have done the parametric equation of the circle. So if I take this angle as theta, this point is going to be a cos theta comma a sin theta. Am I clear? If you take a point on this, say this is P. So this point P is a cos theta comma a sin theta. Now you drop an altitude from P on the major axis. So if a altitude is dropped from P on the major axis, now x coordinate here is going to be again a cos theta. And in the equation of ellipse, if I put x as a cos theta, I get cos square theta plus y square upon b square equals to 1. So y has plus b sine theta. So it is a cos theta comma b sine theta. Got it? So this is the parametric point on the ellipse. See, remember one thing. If this is the ellipse you have, got it? If this is the ellipse you have, having major axis as its diameter. Now, if there is a point a cos theta, comma b sine theta, so this angle theta, it is not theta. Remember this thing? This angle is not theta. Theta is which angle? Now, if there is an ordinate dropped from this point, so wherever it meets the auxiliary circle, this angle is going to be theta. I'll mark it with another pen. See this triangle. So this angle is going to be theta. Am I clear? This angle is going to be theta. Make sure you do. This is a very common mistake that students do. They're taking a point a cos theta comma b sine theta and taking this angle as theta. Not correct. Got it? Now see, if the ellipse is of this type of shape, got it? Now its auxiliary circle will be like this. This is major axis, which is y-axis. Minor axis is x-axis. Now, if the ellipse is x square upon a square plus y square upon b square equals to 1, then equation of auxiliary circle is going to be x square plus y square equals to b square. Now, any point on this auxiliary circle can be taken as b cos theta, comma, b sin theta, so that this angle is theta. Now you drop a perpendicular from this point on the major axis. So here, y coordinate is going to be same, b sine theta. And if you, in the equation of ellipse, if you place y as b sine theta, you are going to get x as a cos theta. Got it? So this is how we define parametric equation. This is a parametric point with a parametric coordinate as a cos theta, b sin theta. And if you want to see the equation is x equals to a cos theta and y is b sin theta. Got it? Chandu, understood? Now, point and the ellipse. See, if we have to assume two different points on the ellipse in terms of, say, alpha beta parameter, so points can be a cos alpha b sin alpha and a cos theta b sin theta. Got it? Now point on the ellipse. Now see, for a ellipse, x square by a square plus y square upon b square equals to 1. A point x1, y1 can be outside the ellipse. It can be on the ellipse or it can be inside the ellipse. So if equation of ellipse E is x square by a square plus y square by b square minus 1 equals to 0. And for point x1, y1, there is a quantity defined E1. x1 square by a square, y1 square upon b square minus 1. Now, if this E1 is more than 0, then point lies outside. If E1 is equal to 0, then point lies on the ellipse. And if this E1 is less than 0, point lies inside the ellipse. Am I clear? So this is how the pattern of a point. Got it? So this is how the pattern of ellipse works. Am I clear? Now, the very important thing, line and ellipse. Line and ellipse. Now, a line can intersect the ellipse. A line can be, if this is the line, a line can intersect the ellipse at two distinct points. A line can touch the ellipse. A line can go outside the ellipse. Got it? Undoubtedly, this is a very important case for me when the line is tangent to the ellipse. Got it? Now, how does it work? Let the equation of ellipse be this. And there is a line y equals to mx plus c. Got it? So what do? We solve these two. Got it? We will solve these two. So it is x square upon a square plus y square upon b square equals to 1. And say y equals to mx plus c. Now, how do you solve it? Put this point in the line. So it will be mx plus c square upon a square plus y square upon b square equals to 1. Got it? So it is b square into mx plus c whole square plus a square y square equals to a square b square. Now the strategy is, from this I'm going to get a quadratic in x. Now, if this quadratic is having two distinct real roots, means line intersect at 2 points. Now, if this quadratic is having one repeated root means what? D equals to 0. That means line is touching the ellipse. And if this quadratic is having two imaginary roots, means line is passing outside the ellipse. Am I clear? This is what case I have also mentioned in the parabola. Now, if I simplify it, it is b square m square x square plus b square c square plus 2mcb square x plus a square y square minus a square b square equal to 0. I just made a mistake. This line is not here. Okay. So this is x square by a square plus mx plus c square upon b square. This is how it will work. So it will be a square into mx plus c whole square plus b square x square. So it will be a square m square plus b square into x square plus 2a square mcx plus a square into c square minus b square equals to 0. Now, if you do d equals to 0, you will be getting 4a ki power 4 m square c square minus 4a square into c square minus b square into a square m square plus b square. It should be 0. Clear? Now, if you simplify it, you are going to get c square equals to a square m square plus b square. So, this is the condition for tangency. Condition for tangency means this is the value of c, a square m square plus b square under root, for which y equals to mx plus c will be touching the ellipse. Understood? Now, let's go with equation of tangent in various forms. First is very popular, very well known to us. That is tangent at the point x1, y1. What did I tell you? Whenever we are looking for tangent at the point x1, y1, simply replace x square as xx1 and y square as yy1. Got it? X as x plus x1 by 2 and y as y plus y1 by 2 and constant as it is. So equation of tangent at this point to the ellipse is x x1 upon a square plus y y1 upon b square equals to 1. Got it? Like a simple question if I do, find the equation of tangent to the ellipse x square by 9 plus y square by 16 equals to 1 at a point 3, 4 on it. Yes, how to do? Now 3, 4 is definitely lying on the ellipse. 3, 4, say it is 2. Now it is fine. So what will be the equation of tangent? Replace x square by xx1. So it is 3x upon 9, 3y upon 16 is equals to 3, 4. So it is 4y upon 16. That's it. So it is x upon 3 plus y by 4 equals to 2. This is the equation of tangent to this ellipse. Am I clear? This is the equation of tangent. Now, let me teach you something unconventional. Why did I say unconventional? That is basically reverse process of this. Like if they say if x upon 3 plus y by 4 equals to 2 is tangent to the ellipse x square upon 9 plus y square upon 16 equals to 2. Find the point of contact. So what will you do? See, this is the ellipse. Now on this ellipse, there is a point x1, y1. There is a point x1, y1. And at this x1, y1, the tangent is x upon 3 plus y upon 4 equals to 2. Got it? So what is the equation of tangent at x1, y1? It is x1 upon 9 plus y y1 upon 16 is equals to 2. Now you compare these two. See, how do we compare? Coefficient of x in the upper equation 1 by 3. Coefficient of x in the lower equation is x1 upon 9. Coefficient of y in the upper equation is 1 by 4. Coefficient of y in the lower equation is y1 upon 16. Constant in the upper equation 2, constant in the lower equation 2. Now, if you equate these two, if I equate these two, your y1 will be 4. And if I equate these two, then your x1 will be 3. So this 3 comma 4 is your answer. This is how we reverse compare and find the point of contact. So to get the point of contact, do not ever solve the equation of the conic and the line given to you. Just write the equation of a new tangent and then compare. Got it? Now, equation of tangent in parametric form. So simply, now the point is a cos theta, comma b sin theta. So what is the equation of tangent will be? X times a cos theta upon a square, y times b sin theta upon b square equals to 1. So it is x cos theta upon a plus y sin theta upon b equals to 1. This is the equation of tangent. Like they have written in the form of alpha, equation of tangent at the point a cos alpha, comma b sin alpha on the ellipse. Understood? Take a moment and absorb it. Now, equation of tangent with slope m is to be to this ellipse. If you remember, y equals to mx plus c is tangent to the ellipse x square by a square plus y square upon b square equals to 1 if c square is equals to a square m square plus b square. That means c is what? Plus minus under root of a square m square plus b square. So you just replace this value of c here. So y equals to mx plus minus under root of a square m square plus b square. This is the equation of tangent to the ellipse in slope form. Got it? So y equals to mx plus minus under root of a square m square plus b square. It is the equation of tangent. Now to get the point of contact, again, see, let me see y equals to mx plus under root of a square m square plus b square. You are trying to get it point of contact on the ellipse. So again, what do? Write the equation of tangent, add some x1, y1. So x1 upon a square plus y1 upon b square equals to 1. Correct? So above equation can be written as mx minus y is equals to minus under root a square m square plus b square. Now compare again. Comparison if you do, in the above equation, coefficient of x is x1 by a square. In the lower equation, coefficient of x is n is equals to, in the upper equation, coefficient of y is y1 upon b square. Lower equation, coefficient of y is minus 1. That is also constant in the upper equation is 1 and constant in the lower equation is a square m square plus b square. So your x1 is minus of a square m upon minus of a square m upon under root of and y equals to b square upon. Understood? So this is how we find the point of contact of a given tangent. Exactly the way I have done it here. Have a look. If the line x upon 3 plus y upon 4 equals to 2 is tangent to this ellipse, find the point of contact. So I use the same method. Got it? So write the equation of same line that is tangent in two various forms and then compare. Now, and this is what they are also trying to prove. Got it? Now, all right. So few things we will do. Like write equation. Find the equation of common tangents to the ellipse x square by a square, y square by b square equals to 1 and x square by b square plus y square by a square equals to 1. Give it a try. You need to write the equation of common tangents to the ellipse. If you remember, tangent in the slope form, tangent in the slope form has nothing to do with which is major axis, which is minor axis, which is greater, which is lesser. It is simply using A or B the way they are. See, I have done the entire proof of condition of tangency. Nowhere they are using about the major axis or minor axis. They are simply using C square is A square M square plus B square. So if I look for the tangent of this ellipse, tangent will be y equals to mx plus minus under root of a square m square plus b square, correct? For the second equation, tangent will be y equal to mx plus minus under root of b square m square plus a square. Now, if these two tangents are common, they are same tangents, that means this is also equal to this one. So it will be so m square is going 1, so m going plus minus 1. And yes, what it is supposed to be, there are supposed to be 4 common tangents. You know, one is this one. Other is this one. Then another one is this one. And the last one is like this one. Got it? So this is how we got the equation of 4 common tangents to these two ellipses. Now, director circle. Director circle is what? Locus of a point from which two perpendicular tangents can be drawn to the ellipse x square upon a square. Yes. Locus of a point from which two perpendicular tangents can be drawn to the ellipse. Got it? Now, how to do? Now see, this is the ellipse given to you. Now let us assume there is a point externally h comma k. From this point, you are trying to draw two tangents. One is this one and other is this one. And this is somehow the angle between these two tangents. Got it? See, let y equals to mx plus under root of a square m square plus b square is a tangent to the ellipse. Got it? Now it is passing through y equals to mx. So it is passing through h comma k. So that means k equals to mh plus under root of a square m square plus b square. So it will be k minus mh is under root of a square m square plus b square. Square both sides. So k square plus m square h square minus 2mkh is a square m square plus b square. Got it? So it will be k square minus a square into m square minus 2mhk plus this is not k square, this is h square plus k square minus b square equals to 0. So this is a quadratic that you got. Am I correct? Now let us assume m1 and m2 are the slopes of these chords. Say this is for m1 and this is for m2. Now according to their problem, this m1 and m2 are perpendicular because we are looking for the locus of a point from which two perpendicular tangents can be drawn to the ellipse. So that means m1, m2 is minus 1. So it is k square minus b square upon h square minus a square equals to minus 1. So k square minus b square is minus h square plus a square. So locus is x square plus y square is a square plus b square. Locus is x square plus y square is equals to a square plus b square. Understood? Have a look. So this is the equation of director circle. Now, like if I ask you, so if I ask you for the ellipse x square upon 16 plus y square upon 10 equals to 1 and x square upon 7 plus y square upon say something b square is equals to 1. They have this and this have same director circle. Same director circle. Then find b. Now, equation of director circle of this x square plus y square is 26. Equation of director circle for this x square plus y square is 7 plus b square. Yes or no? Now, if these two circles are same, center is already same 0, 0. So, if these two circles are same, means 26 is equals to 7 plus b square. So b square goes 19. Am I correct? B square goes 19. That's it. Now, have a look at this question. If this line touches the ellipse x16 x square plus 25 y square equals to 400, then find the value of k. Give it a try. Options are there in front of you. I'll run NPS for you guys. So whenever you solve it, mark your correct answer in this poll section. Yes. Quickly try. Condition is what? If the line is written in the form of y equals to mx plus c, see, nobody has been able to mark it. If the line is in the form of y equals to mx plus c, then c square is equals to a square m square plus b square. First of all, ellipse is x square upon 25 plus y square upon 16 equals to 1. Got it? Now, line is y equals to minus 3 upon 5 into x plus k by 5. Line is equals to minus 3 by 5 into x plus k by 5. So, this line touches this ellipse. So, in that case, c square should be a square m square plus b square. Now, c square is k square upon 25 is a. A square is 25, m square is 9 upon 25 plus b square is 16. This is cancelled. This is cancelled. So k square is equals to 25 into 25. So k equals to plus minus 25. Have a look at it. Have a look, everyone, quickly. Got that, everybody? So line touches this ellipse, then very simple condition. C square is a square m square plus b square. All right. Now, say this is a very important equation of chord. This point P alpha, that means it is a cos alpha comma b sin alpha. This is a cos beta comma b sin beta. Now, equation of chord of the ellipse joining point P alpha q beta is x upon a cos alpha plus beta by 2 plus y upon b sin alpha plus beta by 2 is equals to cos of alpha minus beta upon 2. Got it? So this is what you have to remember. x upon a cos alpha plus beta upon 2 plus y upon b sin alpha plus beta upon 2 is equals to cos alpha minus beta upon 2. See, let's do a question. This is an ellipse given to you. Now, there are 2 points P alpha comma beta.